Hey everybody, we're here today and it's going to be kind of a little detour. It's going to seem weird, but it's going to tie back in a little bit. We're going to talk about breaking down square roots. And like I said, I actually thought if I was making this textbook, I would have done this probably in our exponential unit. But I was like, oh, I guess you don't do that this year. I guess it's in Algebra 2. And then, lo and behold, it's right here. So, I'm going to show you guys how to break down square roots. Basically, you're going to use this a lot because we've talked previously. Square roots are the biggest single group of irrational numbers that exist. And because of that, if you wanted to square root something to get your answer, you're going to have to estimate it because you're going to have to round eventually because that number goes on forever. So if you break down the square root instead, you can leave your answer in terms of a radical, and then therefore it's going to be an exact answer, which is going to be way better for us. So let's say something like the square root of 45. So 45 is not a perfect square. I think we can all agree with that, right? If it was a perfect square, that would be easy. If you get perfect squares, you can still obviously take those perfect squares. Just remember that when you square root something, you're going to get a positive and negative answer, so you got to have both. That's important. However, square root of 45 is going to give me some decimal. It's definitely irrational. But what I want to think about in here is there are some things that I know I can take the square root of, right? Are perfect squares. So off the top of my head, you know, we got 1, 4, 9, 16, 25, 36, 49, right? I guess 64, 81, 100, right? And if it helps you, I remember doing this actually when I was in school, just writing those on my paper at the top. But what we want to do is we want to say, can I write 45 as one of these perfect squares times something? And preferably, you want to work higher, like the highest one you can possibly get. Because otherwise, you're going to have to do it twice, which you definitely don't want to do. So obviously, 36 times something is not going to get you 45. 25 times 2 is 50, no good. 16 times 3 is 30, 48, close. 9 times 5, however, is 45, right? So, with the properties of square roots, I know I can write this as 9 times 5, like that. And there's this really cool property in square roots that says that if you're taking the square root of a product, it's like taking the square root of both numbers and multiplying them together, like this. So I can rewrite 45 as 9 times 5. I can rewrite square root of 45 as square root of 9 times the square root of 5. And then what's cool is we actually know the square root of 9, right? It's a perfect square. So I know that the square root of 9 is positive and negative 3. But the square root of 5 does not break down. So I'm going to leave my answer plus or minus 3 square root of 5. So basically, we did it one step at a time. When we find our perfect square that we can write it as, we can take the square root of that number. We leave the other number in the square root still. So in my problem, instead of writing this decimal that's irrational, goes on forever, I can instead write 3 square root of 5 and negative 3 square I can instead write 3 square root of 5 and negative 3 square root of 5. And actually use that in my calculator. That's going to give me that exact answer instead of rounding it off a little bit. Yeah, pretty cool. So if you get to something that's large and in charge that maybe you don't know, like let's say you have 98. right? And you're not sure which one, you know, if there's a perfect square that goes in the 98, you can always use your factor tree, right? And we can do the prime factorization. So 2 goes in the 98. That's going to be, what? 49. Oh, 49 is not prime. And 49 is 7 times 7. And those are prime, right? So, anytime we end up with the same number here, right? The same prime number, 7 times 7 is 49. Yep, you're darn right it is. Then that tells you that this is a perfect square because we had the same thing. So I can use my factor tree and just kind of break it down until I find one of those perfect squares. Anytime that we have a pair, it doesn't necessarily, like maybe if I would have done this a little differently, maybe it wouldn't have turned out to be like that, right? If I would have just done 7 at first here, I'll show you. So let's say I pulled out a 7 here, because everyone knows 7 goes into 98. So that goes in 14 times. And then we break down 14 as 2 times 7. Anytime you have the same number, that's a match, that's going to be your perfect square, whatever those two numbers multiplied together are. So if you have, you know, be careful with the 2's, because it might be 4 times 4, you know, with 16 or something, even though it's 2's. But you should have 2 sets of 2's then. So really you're just looking for these matches in your factors. If you have that match, that's the perfect square that you want to go to. Some of you are probably never going to do that, and you're just going to be like, oh, look for the perfect square that breaks down and go from there. So, for example, right, we just said that this is 49 times 2, and we know that that is just the square root of 49 times the square root of 2. And the square root of 49 is positive and negative 7. And then we just leave it square root of 2 on the outside. And that is the quick way of how to break down square roots. Not too bad. Like I said, using your perfect squares will really be helpful, especially if your number sense is not great. Just having those memorized up to, you know, really up to 15 is good. And then, you know, use your calculator, right? Divide by, you know, whatever 225, if you want to see if it's divisible by 225, right? Whatever it is. But that will kind of help you guide into what you're looking for here. And obviously, when you're done, make sure that whatever's in the square root is not able to be broke down any farther. Right, so for example, if you had 12 in here, well, I could rewrite 12 as 4 times 3. So I could still pull out more numbers there. Really common square roots to have at the end are square root of 2, square root of 3, square root of 5, square root of 7, stuff like that. You know, definitely some prime stuff. But it doesn't, you know, doesn't have to be. You can have square root of 6 at the end. You can't break that down. So, yeah, that's kind of the gist, right? Let me know if you guys have any questions. Obviously, office hours, Monday, we weren't in school, but I'll still be there Wednesday. And if you guys need anything, I will be there. All right? Have a great day.